Okay, today's lesson is 13-3 Sum and Difference of Angle Identities. So what we are doing is we're going to be using sum and difference formulas to find angles, measures of angles that aren't specifically on our unit circle. And we're going to use the unit circle to do that. So here are your identities, the sum identities, okay? Sine A, cosine B. So A and B are your two different angles. Sine of the first one, cosine second, cosine first, sine second. Straight up, I don't want to spend time on the video going over those. You've got them. We're going to make sure you know how to use them, okay? Now, one of the things when we're going through and doing this first one is tangent, so I'll make sure we can still see that, is I have these steps color-coded throughout the whole video. So throughout this lesson and the next lesson, if you follow what I'm doing and understand my system, then you might not have to watch the whole video if you don't want to, okay? Because you got a lot going on these days. All right, so first off, what we're going to be doing, we're finding the exact value of the tangent of 15 degrees. So in my steps, the first thing I'm going to do is find two numbers on the unit circle. So every step that I do in pink on these videos is me finding two numbers on the unit circle that give me 15. Okay, so obviously I'm not going to add two of them, so I'm going to subtract. Most importantly, y'all, there is more than one way to do this. There are more than two numbers that can subtract to give you 15. The ones I choose, if I can find any in the first quadrant, those are the easiest ones to use. So I'm going to start off with tangent of 45 minus 30, because 45 minus 30 is 15. So the next step is to apply the formula. So the tangent of 45 minus 30 is the tangent of A minus B. So that says tangent of A minus tangent of B over 1 plus tan A tan B. So every time I write the green step, I'm applying the formula to those two numbers. So that's what that looks like. Tangent of the first angle minus tangent of the second angle over 1 plus tangent of the first times tangent of the second. Then the next step, I'm actually evaluating that. And so when I write that step, y'all, I write it like this, because those parentheses mean that I'm going to figure out a value that goes in here, a value that goes there in each set of these parentheses. What is the tangent of 45? It's 1, so it's going to go in those parentheses. What is the tangent of 30? Square root of 3 over 3, so it's going to go in those parentheses. And then the last step that we have is to simplify. So everything in purple is just simplifying this expression. First, I'm going to get rid of the complex fractions. So I'm multiplying the top and bottom by 3, which is my least common denominator. And when I do that, I get 3 minus the square root of 3 over 3 plus the square root of 3. I cannot leave a radical on the bottom, so then I multiply by the conjugate of my denominator, which is 3 minus the square root of 3. So when I multiply that out, I get this. I'm foiling the top and remembering my a squared minus b squared on the bottom. And then when you simplify that, you get to this. 9 plus 3 is 12, of course, and 9 minus 3 is 6 on the bottom. And that simplifies even further because 6 goes into all three terms. And so I end up with tangent of 15 degrees equals 2 minus the square root of 3. So all the way through the video, I'm going to be using these steps and these color codings. So hopefully that will make it easier for you as we go through. Okay, radians can tend to be a little bit problem. Find the exact value of the cosine of 7 pi over 12 because people aren't so, or just have a little bit of a bad relationship with fractions sometimes. But hopefully this will make it easier for you. So if I'm looking for two numbers that add or subtract to give me 7 pi over 12, I'm going to think of two numbers less than 12 that add to give me 7. Okay. Again, you can use there's more than one choice here. Okay. So the first thing you might think of, let's go with two numbers that add to give me 7. Okay. I'm thinking of, I didn't have this written down, so I'm going to write it. 3 plus 4. That looks like a 4. 3 plus 4. Okay. If you put both of those numbers over 12, okay, I probably should have done that in pink. But anyway, if I put both of those numbers under 12, then this reduces to 1 over 4 plus 1 over 3. Well, those two are values on my unit circle, pi over 4 and pi over 3. So, again, you can do add, subtract, whichever ones that you want that makes it easy for you, but that's just a way to come up with those two numbers if you can't do it easily. So, cosine of 7 pi over 12 is the same as the cosine of pi over 3 plus pi over 4. Okay, order doesn't matter when we're adding. My next step in green is applying the cosine addition formula. And that says cosine of the first angle, cosine of the second angle minus sine of the first angle, sine of the second angle. Okay, and my next step is going to be evaluate. So then I put my parentheses because I'm going to go evaluate the cosine of pi over 3 and put it here. Cosine of pi over 4. So cosine of pi over 3 is 1/2. Cosine of pi over 4, square root of 2 over 2. Sine of pi over 3, square root of 3 over 2. And the sine of pi over 4 is square root of 2 over 2. When you simplify that, and y'all, I'm pretty sure most of the time your denominator is always going to be the same number if you've done this correctly. So my denominator is 4 in both cases, square root of 2 minus the square root of 6 all over 4. Okay, this is the minimal amount of work that I should see on these problems. If you have a calculator that goes straight from cosine 7 pi over 12 to that, you better show me this in your homework if you want full credit for it. Okay? All right, a different type of problem that can come with this. Evaluate the expression of this given the sine of u is 1/5 with u being between 0 and pi over 2, and the sine of v being negative 5 over 13 with v being between pi and 3 pi over 2. Okay, so there are no numbers to begin with. So the first thing I'm going to do to this problem is not pick two numbers in pink. I'm going to go to my green and apply the cosine subtraction formula, difference formula. And that says cosine of the first times cosine of the second plus sine of the first times the sine of the second. Well, then I put my parentheses because I got to go figure out what those numbers are. So if I am told that the sine of u is 1/5, I'm going to come over here and to find u, I'm going to remember that x squared plus y squared equals r squared. Sine is y over r, so that means I'm looking for x. And so x squared equals 24, and x equals plus or minus. Very, very important for you to remember that. Okay, how do I know which one I want? Well, if you go back up to the top, it says u is between 0 and pi over 2. Well, that's the first quadrant, which means my signs are plus, plus, and that means I want the positive x value. So x equals 2 square roots of 5. And that means if I know the sine of u, now I can find the cosine of u, which is going to be x over r. So why did I write a 6? Because I didn't simplify it correctly here. Okay, well, let me fix that really quick, y'all. That's supposed to be a 6. Okay, I was clearly distracted. Okay, so that's 2 square roots of 6. Sorry if you were yelling at the video. So cosine is 2 square roots of 6 over 5, and tangent is y over x, which is going to give us 1 over 2 square roots of 6, and then I just simplified it because you don't want to leave a radical on the bottom. So cosine of u is square root of 2 over 6, so I'm putting that in right there. Sine of u was given to me in the problem, so I'm putting that one right there. Now I have to go find v. So I'm going to come over here to find v. Again, x squared plus y squared equals r squared. V is, sine of v is negative 5 over 13. And I tell you all the time that when you have a negative, it's squared and it's going to come out positive. So I don't write the negative in that problem because everybody makes mistakes when they do. So x squared equals 144 and x equals plus or minus. What the heck? Why did I say that it was 3? Okay, it is clearly not 3. It is 12. Okay, that's hilarious. I was clearly talking. Anyway, so what quadrant is V in? It's between pi and 3 pi over 2, which is the third quadrant. So I have negative, negative, and that means that my x value is negative. So my cosine is going to be negative 12 over 13, and my tangent is going to be negative 5 over negative 12, which becomes positive 5 over 12. And I did the tangent, y'all, mainly because we have to do it in the next problem. You could have clearly stopped at the cosine. So the cosine of v from what we just did is negative 12 over 13. Sine of v, they gave it to me. So now I'm going to simplify. So now it's going to be in purple because all I'm doing is simplifying all that I have right there. Okay. Now, this is a carryover of that problem. It's part B. So I did the work here with the tangent problems. And so what is the next step? Again, no pink because I don't have any numbers I'm trying to figure out from the unit circle. So my green is applying the formula. That is my tangent difference formula. Okay. And then my orange is going to be setting up my evaluation. Okay. Let me go up a little bit so I can see tangent of V. So tangent of U from top right is square root of 6 over 12. Tangent of V is 5 over 12. And I put the same thing down there. Again, coming to my purple to simplify. And this one is not so, oh, you know what? I multiplied top and bottom by 12 times 12 because that's what I have right here. I have 12 times 12. So I multiplied by 144, which gave me this. Okay. And then from there, I'm going to multiply by the conjugate of my bottom. And I'm doing this for those people who don't have calculators that do it for them. Okay. And to simplify that, I FOIL the top, a squared minus b squared on the bottom, and then simplify. So that one's kind of yucky, but it's all good. All right. This is the last problem. Simplify the expression. It just says simplify, y'all. So what am I going to do? Apply the formula. And when I apply the formula for a sine sum, then that looks like this. It's the sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. And as I said, the next step is to evaluate, and I can evaluate the cosine of pi over 2 and the sine of pi over 2. So I write that next step somewhere, putting parentheses where I'm actually going to put a number. What is the cosine of pi over 2? 0. What is the sine of pi over 2? 1. And so you'll see sine of x times 0, that first term is going to go away. Cosine of x times 1 is just cosine of x. So that is 13.3, sum and difference. Please email me or come see